Thank you very much for having me, Abbie, to talk about these questions. And Jacob and I did meet with Abbie to kind of coordinate this. So hopefully it looks as coordinated as we discussed. So one of the things I said, I think multiple Society of Research Adolescent meetings ago, somebody asked me, what do I see as being some of the biggest issues in longitudinal science going forward? And I said, I often hear from people that they don't have the statistics to answer the questions they want to ask. And I said, that's actually not our problem. And as you saw from what Jacob showed and what I'm going to go over, we have many tools at our disposal to answer questions. What really is the problem is that we don't have really great questions, and we don't have the kind of understanding, as Jacob was talking about, with things like functional form. So when you're dealing with longitudinal data, when you're interested in developmental change, you actually need to understand what is the stability and instability, or continuity and discontinuity of what you're looking at. And so in my mind, the biggest thing is to have really good questions, because we are no longer in a position where we don't have the tools to answer it. We have lots of tools to answer these questions. With machine learning, we have even more tools coming online. So it really is about the question, and I'm going to talk a lot more about that today. So to overview my talk, I'm going to talk about what kind of questions motivate the selection of whether you approach something as a variable-centered and person-centered. And just so you know, I don't actually like this distinction, but we'll kind of get into why it's kind of question specific as to how you make a decision about whether you want to look at kind of groups of individuals or particular kind of classes of people across time, or whether or not you're doing something with variables, you're constructing variables or looking at variables across time. And I'll show you two examples of those. I'm also going to talk about, many of you who know me know that I use existing longitudinal studies to answer your question, answer my questions. I'm going to talk to you why I do that. It's mostly for power reasons. So I look at differences between groups. I want to be able to generalize my findings to the population. So I use population nationally represented studies, a lot like the ones that are at the Center for Longitudinal Studies, Ireland. It brings you, it makes you puts you in a position of being able to actually answer questions as well as you can and generalize them to the population, versus doing a very small scale study where all you really can generalize to is that sample that you've collected. Examples, and I'm going to show you some examples of the research questions I've used. It's most of the time, if you look up my name, you're going to find almost all of my papers are longitudinal research, though my most highly cited one is a cross-sectional paper. But in general, almost every paper I've done in my career has been on longitudinal analyses, because I'm a developmental psychologist, and all of my questions are really about where do you start and where do you go, and kind of what happens to you in between. So I'm going to talk about, just as I said, everything about any data that you look at, whether you've collected it yourself or not. You need to start with your question. Your question will decide what statistic you use. You don't start off and say, I want to do a latent growth analysis, so what do I do? You start off with the question, of which the latent growth analyses, as Jacob very clearly showed, was the appropriate statistic to use. If you're using secondary or existing data the way that I use, you absolutely need to have your question before you go into that data set. Otherwise, you can just find all kinds of findings that are spurious. So you want to be able to contain yourself and kind of the analysis you're doing by having that question first. And then all the other questions, if you're using longitudinal data, would be things like, where do I think there's change? Where do I think there's stability? Where do I, what is it going to happen when children transition into school? Is it going to be when they transition into adolescence? Like drinking, for example, we wouldn't particularly think we're going to see a lot of heavy substance use, or we hope we don't, at age 5. But we may see that tick up at age 12 and 13. So that may be where we want to start looking for substance use, whereas asking those questions of a 5-year-old would probably garner us not much at all, right? In fact, I hope it would be at 0. But those are the kind of things you have to think through when you're asking these questions. So I use existing longitudinal data, and I'm going to tell you what kind of the advantages are. I've put a citation here, which wasn't one of the papers I sent you. Justin Jagger and I have multiple papers where we look at, or we go through how you select large-scale data sets, how you can think about them from developmental science. I'm going to show you a few reasons why I like them. I use population studies. I'm going to show you an example of using the British cohort studies. I've used the NCDS. In fact, I'm doing a replication with the NCDS now. I've done replications with the Millennium cohort. In the United States, I use the ECLS-K, which is a kindergarten through 8th grade data set that has 20,000 children in it, representing the United States of children in education. Sorry. They also have one that's a birth cohort, the ECLSB, Fragile Families, which represents urban centers of the United States. The panel study of Income Dynamics Child Development Supplement, which I originated. So that's actually a study I designed, but is a population study that's connected to the panel study of income dynamics. The NLSY is also, it's done by the Bureau of Labor Statistics. So these are all ones that are available and look specifically at children and families across time. They're developed by consortiums of researchers, primarily ones that are sociologists and economists. So we don't have a lot of developmentalists other than the Fragile Families and PSID both had developmental psychologists on it. I think that's a little bit of an issue. You can ask me questions about that later, but nonetheless has really good measurement across time. It's not designed for developmental questions, but they have a lot of measurements that are similar to the ones I'm interested in and study. They're longitudinal, they're representative, so I can begin to address this chronic problem with the weird population in our science of overrepresenting the kind of Western European industrial, I never remember all these things for this, but basically the UK, US, Germany all fit into this category. And they generally have large sample sizes that help with power. Because I look at different groups, I need power within those groups in order to find differences and not just spurious differences. I'm just going to show this quickly. I am going to share my slides. This is from the paper I mentioned. These are all available right now. Please don't do it during my presentation, but if you wanted to look at the PSID, you could go to the PSID website and you could download data right now. Please have a question first. But you could do that. It's free and available. A lot of these other ones are at places like ICPSR, which are the archive data set. Closer in the UK have a lot of these data sets available. But you can just see this is just a sample. This isn't everything that's out there. There's a ton of places where you can find this kind of data. They use widely used measures, like I use ones that use the Woodcock-Johnson quite a bit, which is an achievement test, the Peabody vocabulary test, digit span, which often gets used as a working memory task. I think a lot of people complain about whether it is or not, but most of them have it. It's from the IQ task, it's from the WISC. Problem behaviors, they have social skills rating forms, lots of self-concept of ability. Some of them have executive function. Some have the very early developmental Bailey. They have alcohol and drug usage and the home scale, which I use a lot. Also, as part of being part of the Society for the Improvement of Psychological Science, we now have, and this is where the question comes in, a pre-registration and a tutorial for doing secondary data analysis pre-registration. Again, very important to have your questions first before you walk into the world of existing data, because you can run all kinds of things and find spurious kind of relationships, and you really don't want to do that. You want to have a question first. Some advantages, you can replicate these phenomena. When I just showed you all of these measures, they overlap across different ones. I'm going to show you how we use that to our advantage to replicate. You can enhance research using smaller scale studies. So what do I mean by that? You can take your small convenience or community sample and see if your findings replicate in these larger population studies. You can generalize to the population, and you can use rigorous methods. And what I mean by that, I'm going to show you, you can use things like latent growth curve. These demand a very powerful sample size to use. And so you need to have, you can't just go run 50 people and run latent growth curve, right? So it really, these demand a much larger, more powerful in order to run them. You do have, these are the disadvantages: limited measurement. I'm going to show you how we had to make compromises, lack of multiple measurements within time. This is, Jacob got at this a little bit. If we're with young kids, I actually want to see lots of measurements on a particular thing, because that change is happening really quickly. These go in for a year, 2 years, PSID goes every 5 years. I mean, so that means we're not capturing this kind of really important change within time. And, you know, again, most of these are at least a year. Some of this stuff is changing within months. So you want to, and very few of them are capturing that. So I have no control on the study content. I'm basically, except for the one I designed, I have no ability to decide what it is. I have to take whatever they've done. They may not adequately address some aspects of my question. You have to understand missing data, and you really need to understand how to do data management. All of these say that they're really managed well, and they're managed pretty well, but it never stops. Every time I walk into a new data set of being like, oh my God, like all the stuff I have to manage in order to just get to the point of actually analyzing the data set. So you have to, and you know, when you're working with 20,000, I do missing data imputations on 20,000 kids. So it also is very intensive, kind of computer intensive. So what are the motivations for my questions? I look at the issue of maths, which I change at different points for this audience. Math skills, multiplication, division, fractions are primary distinguishing predictors of youth who end up in educational careers with college degrees. I have a lot of thoughts about what that is, but right now it is a distinguishing factor in whether or not in the United States you get into a 4-year college program. I think it is also that way in the UK. The mastery of fundamental math skills is linked to higher wages in adulthood. So this is all economic information coming out. The widening gaps are skill gaps, so that the ones with higher skills are doing better and getting higher amounts of money. And research using multiple US and international data sets indicate that early math skills are the strongest predictor of future academic success. We have other studies that show exactly the same. We can, and I'm not happy about this, but we can look at data from 54 months and we can predict in the United States who's going to end up going to a 4-year college. It's that stable and that predictive across time. So I'm going to talk about the person-centered approach and what brought this question on. So in the United States, we have an achievement gap. It used to be a relatively large race achievement gap. That's actually reduced. What we have now is income and education, so a socioeconomic gap that's really growing, and this gets back to these skills. We still have the race gap. It's not like we haven't had it. It's just that the socioeconomic status gap has actually created even larger gaps than the race gaps. So my question for this, when I went into it, was that there was a lot of data coming out from my colleagues about these stable race gaps. We weren't reducing them across time. And it occurred to me that one of the issues is that, and this is an ongoing thing, when you use categories like race or gender or nationality, everyone becomes the same in that group. So if you're white, you now represent everybody, even though there's tons of heterogeneity within each of those groups on how they're achieving. So I wanted to answer the question, is it the fact that when we look at these gaps, if you look at the highest performers or even the lowest performers, they look about the same. People who are performing at a really high level are kind of performing in the same area. The problem is with race, they have a lot of people in their group that are performing at the really low level, and that's pulling those averages down. So if you're just going to do a between group analyses, if you're just going to be looking at averages, you're missing the fact that there's tons of heterogeneity in those achievement trajectories. So the way to answer that question, when you want to look at heterogeneity, when you want to understand whether or not within something you're looking at that there's so much heterogeneity, you want to parse it out and see if there are interesting classes of group, people who kind of hang together and look similar. And now you want to look at that. Then you go to something, which is what we did. Justin Jagger and I, we looked at latent class growth analyses, which is a form of latent analysis, growth analysis, but now we're looking at classes. So we're now pulling this across. And I can tell you, I did use M+ to do this. I have a very love-hate relationship with N+, but it has some advantages. And I would also say, I mean, one of the things that I think most of us who do a lot of statistics, we move in and out of programs all the time in order to find the ones that do the best. Stata sometimes works best for me. It really does population weighting easily. So, you just have to kind of find the place you want to be. In this case, I wanted to have with the latent class growth, I wanted to be able to distinguish my classes, and M+ has a very nice set of 3 to 4 different ways you validate whether and what the classes are that you're getting. Are you getting 3 classes? Are you getting 4 classes? Are you getting 5? So that advantage in M+ is why I chose to use this. R is trying to catch up with this. It's still not as easy to do some of these more complex ones in R, but there is plenty of code out there to try to do this. So my question was, are there different types of achievers within race groups? It's a question of heterogeneity. I needed a data set that I could look at this that had good representation of race groups, had enough in that I could adequately represent them. And because I wanted to generalize to these racial groups, and so I wanted it to be nationally representative. So my choice was the ECLS case survey, the one I told you about, goes kindergarten through. In this case, we did 5th grade, and the reason we do 5th grade is because in the United States, the 8th grade has changed to what we call a junior high, and now choice is being made based on your earlier skills as to whether or not, for example, you're in algebra when you're in 8th grade. And so I didn't want that discontinuity that happens in the United States school system to come into this. I wanted it to have the continuity of what we call the primary grade progression. So mine goes kindergarten through 5th, because I didn't know what to do with that 8th grade time point. And I just didn't want to confuse the situation any more than this huge analyses I was doing. All right, so here we have, for white children in the United States, you see this heterogeneity, this distribution. And so the very first question is there heterogeneity in achievement? And the answer is yes. You see this gap, and you see it growing across time between the highest achievers and the lowest achievers. We're actually seeing something we never want to see, which is a beginning of a plateau. These lowest achievers, they're not growing at all. We basically don't want to see that ever. And you see the highest achievers plateauing a little bit, but still kind of continuing. Then the question is, what about other groups? And because I have the kind of representation, I can look at these different race groups in the United States. So we see a very similar situation in each of the groups where they're starting off separate. And I'm going to come back to that. That's another important part. And many of them are growing apart from each other. In the paper you'll see that we do identify catch-up groups where some people start off very low and then actually get up to the higher ones. Very few of those, very few people are represented in that, but there is some catching up across time, because otherwise when you look at this, you're like, your fortune is determined at the entry to school, and you just kind of live out your trajectory across time. I will say for the majority of the population in the United States, that's true. We do have subgroups that do switch over. They go from kind of low performance to high performance. This is mostly in our Hispanic and Asian groups. And I think those are people basically kind of learning the language. Once they start kindergarten and learn, then they just kind of take off in schooling. They probably would have been in our highest trajectory to begin with. The other thing my question was, is everybody at the same place? If you're a high achiever, and the answer is no. So within the groups, high achievers start off at different spots and they end up at different spots as well. And you can see that kind of across. There's some of them that look the same and some that look quite different. Also in the paper, you'll see that there are different percentages of the population within each of these within race groups. So there are groups that represent the highest achievers much more strongly than other groups. So it was fascinating to be able to do this. I was able to answer the question of, is there heterogeneity? Please note that in the white population, it's kind of the most heterogeneity, right? We have the most heterogeneous groups. We're finding the most different classes, which is why again, in these categories of putting everybody in the same race groups, we lose all of that heterogeneity that's actually happening within the groups. The United States is a melting pot. No matter what our politicians want to think about that, it is a melting pot. We have a lot of different people that have come to the United States. And so saying that somebody is white, Black, Hispanic, or Asian, we saw this just recently in our politics with calling everybody Hispanic, that you lose the heterogeneity that's in there. And so this is a way of explaining it. So achievement gaps exist prior. This is a big statement. I came out of this, and I say this over and over again. This is true for every trajectory analysis I've ever seen in the United States. Those gaps exist on entry. The schools do not create the gaps, they sustain the gaps. So one of the issues we're worried about with COVID-19 is that we know those gaps already exist. And for the first time, we believe we're going to start seeing, usually they're going up. We think we're actually going to see those trajectories go down. We already have some evidence that the students in the United States are losing instruction time and education across time. So we now are going to have even more problems with that achievement gap, as we now have to pull them even back to the kind of national averages, which aren't great, but at least they're on the upward trend. There are different trajectories within race. Groups of children start low, catch up. And by the way, those are predicted, those lines are predicted by SES, so socioeconomic status. Variable centered, how did we approach this? This was individual differences in elementary school. This is actually kind of a fascinating story. Bob Siegler was on the National Academy of Mathematics. They're the ones who set policy for the United States. They were sitting around and they're like, well, we know fractions predict algebra. They were going to write this in to their thing, and they had to go look for the paper that actually said fractions predict algebra. Ends up being there was no paper. There was no work. This was just kind of a thing that everyone felt like was true, but nobody had actually studied it. So he actually came to a center I was running, the center that does replication, and said, hey, you know, you guys are doing this work. Is there any way we could look at this question? Because it ends up being we have no work on this, and we would really like to say fractions predict algebra. We all think it, but there's actually no substantial data out there that says it. So we said, we got a group of people together. We said, sure. We looked at the data sets, and we found 2 data sets that allowed us to do this. And to look at algebra, just do fractions predict algebra and do fractions predict total math knowledge. The 2 that we found were the British cohort studies and the panel study of income dynamics. They had addition, subtraction, multiplication, division, and fractions. So they fit all of what we wanted to look at. They had it basically around 10. I said this to Abbie and Jacob. In the United States, we actually had to go 10 to 12 because it ends up being that in the UK, the students meet fraction proficiency at much higher rates earlier than they do in the US. So we actually had to extend the age group in order to get enough kids to kind of match what the kids in the UK. So that was the only kind of additional thing. We still had 10 to 12-year-olds. They were mostly 10 in the British cohort study. And then we go to 16 years of age. These are all corrected for parent education, income, children's IQ, and other factors, and I'll show you those. So here's the big kind of outcome that we looked at. So age 10 math skills for algebra, this is the British cohort studies. You see about a 0.15, 0.16 after controlling for verbal IQ, nonverbal IQ, lots of demographic variables. This is what it looks like. Keep 0.15, 0.16 in mind because we replicated that in the US and look at those similar sizes, 0.17, 0.18, totally different measurement, different data, different population, both nationally representative. It ends up, much to the happiness of Bob Siegler, that fractions indeed do predict algebra and math, total math score across time. So that was his, or this kind of hypotheses going around non-tested was true. The other one that I want to point out is that division, and this ends up in these tests being long division, ends up being also predictive. This was not predicted. This was not thought about, and we were surprised by this finding. And Bob has gone on to think more about why division, because some of you may know fraction is a form of division. So it's kind of interesting that fractions and then separately and independently division are both. And we think it's because the division in these tests was long division, not kind of quick, easy kind of fraction division. And it is that more complex math that this is picking up on, the same with the fractions. But we didn't see this with addition. So again, addition, subtraction, multiplication is probably already all consumed. You can kind of see this on the bivariate models within fractions already. If you're already doing fractions, you're already pretty good at those, right? So they're correlated. This is done with basic regression. So we were working with economists on this, Greg Duncan. This is just multiple regression across time, controlling for earlier, right? So that's another form of doing change. So we're controlling for earlier measures And you see we have digit span on this, passage comprehension. So we're picking up earlier measures, predicting later. So we're testing for change, right, in this. So in this case, fractions and division, long division, are predicting to algebra scores and total math scores. So he was now able to go cite this and say, yes, indeed. So you will see that these, and they replicate British cohort, division, fraction, US panel study, division, fractions. We replicated across 2 countries. Doesn't matter how we look at it. There's a little bit of a difference of ages with, again, the British cohort showing kids meeting these proficiencies earlier, but they still similarly, once you reach those proficiencies, predict algebra and math score. So that's how we use this across these 2 studies, coming at it with a very clear question to begin with, so that we're not just messing around in these data sets. They're very big. We could have added a lot. We were very clear about what we wanted to do. So final thoughts. Your research question is the most important part of your science. If you are a scientist, what you are doing is taking theory or a very well-considered research question in order to answer your questions. It never, methods and statistics never precede your research question. It always is the driver. And so since many of you are early career, I just want to emphasize this over and over. The most fun part of what we do in research in science isn't the statistics. And I will tell you, I love running models. I'm sure Jacob does too. It is very fun to do it, but sitting down and saying why, what is the question, and then seeing the answer to it, I can guarantee you the joy of that is just as fun, right, as doing it. And it is what should drive your science. Then you look at your methods, you look at your measures, you think about, again, if you're a developmentalist longitudinal researcher, you're thinking about, where do I think change is occurring? Where do I want to look for it? What do I want to model across time? What are the functional forms? Which, by the way, we hardly have any information on those, but one can think about them. And then what are the statistics? Because the statistics are absolutely driven by the question. If you came to me and you said, hey, Pam, here's all the stuff that I ran, the very first thing I'm going to ask you is, can you tell me what your question was? Like, what were you trying to find here? Because I can't tell you if your statistics are adequate if I don't understand what your question was. So just going in and running regressions or ANOVAs or t-tests are not going to help you. You got to know your questions. Whether you choose to look at something from a variable or person-centered approach really depends on whether or not you're trying to explain heterogeneity. We're always, in fact, I will tell people this, you can't look at something that's homogeneous. We need variance in order to run statistics. So if you have no variance, you can't run statistics. But how much heterogeneity? Do you think your findings, this is a little bit, some people do this with moderator analyses, but do you think that there's something in your data that is different for different groups? And the heterogeneity in your group is important. And I showed that with the trajectories. And then the other part you can do is try to explain variance in your dependent variable, which is what we did with the regression approach. We were trying to explain the variance of fractions and division in the dependent variable that we had, which was later math outcomes, so algebra and total math score. Getting training in all longitudinal statistic techniques are going to allow you to employ the best for answering your longitudinal studies. You do have to be trained in missing data techniques. You cannot get in the world of longitudinal data and not deal with missing data. You always need to know this. Being able to move back and forth, being able to answer the kind of questions I was able to answer was because I knew the statistic existed and I could do it. Or I would go find the statistic for the question, right? So having that kind of training will allow you to very quickly say, I know we can do that. Oh, that question is one about heterogeneity. So you think that there's other groups kind of hidden in this larger group. Okay, we can do that with latent class growth analyses. So when you know all of these statistic techniques are available, and I can just throw it out there to you, they will be, then you'll be able to answer any question that you have. All of these data sets allow you to do longitudinal analyses. It takes a lot of time. It's a lot of money to collect really excellent longitudinal data. And so if you are going to do this on your own study, you need to plan for that ahead of time. And sometimes while you're waiting to collect your own longitudinal data, you can utilize some of these other existing ones to kind of get at some of the effect sizes you might want to use in order to think about powering your own analyses. So you can kind of go back and forth between using primary data collection and secondary data sources or existing data to do these as well. Or maybe you have, you know, an excellent mentor who's like, hey, I've got lots of longitudinal data. Let's come up with a question and figure out what we find. So I want to thank you for your attention, and the CLSI for inviting me, and Jacob for introducing all of this. And I'm happy to answer any questions.